What's up, everyone? Welcome back to Better Biomed. Folks, today I've got a rather unusual item, but it's a rare item that we normally don't get the opportunity to take part and diagnose, and that is going to be this guy right here. We actually do find these in hospitals, usually on first floor near loading docks and sometimes in hallways outside major areas like operating rooms. These guys here are designed to lure insects into them and either trap them with sticky things or with an electrical grid like this guy here. Now, warning, these guys are high voltage, and the high voltage is what they actually use to arcy spark and kill whatever gets in there. So there are other types of these, like I said, that use sticky things, and then there's some that use fans to suck them in. This one here uses an electrical grid, which also means that it has to be maintained. So these things will get dirty. They do have to be maintained. And I'm going to show you guys right away how you can do that. And you can see, first off, I've got this right here. There's a collection or kill tray in your bug zapper. And that guy's going to come out. We're going to go ahead and put him over here. That guy has to be cleaned pretty frequently. But most people don't realize that these guys here also have these grids that can also be removed. And they're spring loaded, so you just pull them down. And mind you, I'm not plugged in. Watch what you do with these guys. Make sure that they're not plugged in. Like I said, it's high voltage, right? So I've got this side pulled out. This allows me to clean the grid. The grid is only on one side of the UV lights. And that is right. I said UV or fluorescent tubes, what you're going to have in these. And that is what is going to attract the insects. So we're going to go ahead and pull that out. We're going to pull this side here. And this is where you would get out your soft bristled brush, like this guy here. And you would go ahead and brush it out and clean it. You're going to have all sorts of stuff stuck up in there. So just be mindful of that. I'm going to put these metal parts over here to the side because we're going to be troubleshooting it. And guys, since this is going to be an electrical appliance, you can see I have the hanging chain on there. It is not safe to proceed, even in a contained environment, with a dangly metal chain. So you can see that I'm going to pull that guy off, and I'm going to place that also over to the side. And my other metal items, let's pull them off. Let's pull all this stuff off. There. We're pretty much as safe as we can be. And I'll tell you what, I'll make it even one step better, because we're dealing with high voltage and low amperage. We're going to go ahead and put on some gloves. That'll give me some level of isolation. There we go. I'll tell you what, let's also pull off that metal watch right there. Do not need any of that stuff on while I'm testing this guy. So I'm going to pull this cord out. I'm going to show you guys exactly what it's doing or what it's not doing. I'm going to lay it down here. And when we flick it on, nothing happens. It could still be live. This grid could be energized right now, and I would not know. So what I'm going to do is I have some of these electrical isolated screwdrivers, and I'm going to take this little piece of solder and I'm going to tape it to the end. Now, this is not an official way to test these things, guys, but it will do. And this is plenty safe enough for what I need. Okay, you can see my overall tool, and this grid right here, this is solder that's on the end, very low melting point, and if this grid is live, it should spark. Aha! See that? So that's why you don't want to touch it. It doesn't look like it's on. It is definitely on. You hear that spark? That's the discharging of the high voltage rail, and then it re-energizes. See that? I can put it on there. Now it's recharging the caps. Now I'm going to assume that this is a Gen 1 AC device, which means it is all AC powered. I'm assuming that the way this works is there's going to be a ballast for these UV lights. Let's go ahead and pull this guy off so I can use this as my pointer. So these UV lights right here are going to have a ballast, and that's going to excite the plasma in the tubes and cause them to emit light, basically. I mean, how else should I put it? This grid right here is going to be on a ballast, or it's going to be on a step-up transformer. I don't know. A Gen 1 device runs completely off AC. There's not going to be any DC. So we're going to take this guy apart and we're going to find out. Okay, let's go ahead and unplug him. That's this guy right here. And let's make sure that it's discharged. Yeah, you hear that? Even though it's unplugged, it definitely had a charge. There we go. Okay. So now we're down to no bolts. Good. Not a very scientific tool, but it does work. And just the same as if you're discharging capacitors that you're going to throw away, that's another thing that you can do is isolate yourself like that with a piece of solder and then discharge a cap, especially if you're not intending on keeping it, because that can damage caps. All right, so I'm going to save that flat blade right there, and I need a number 2 Phillips. All right, so the frame of this is extruded aluminum up here, and it's got these caps that are kind of making it nice and neat and pretty. But there's 2 Phillips down here on the bottom, and there's 2 Phillips up here on the top, and that should separate this guy completely. Now the power switch is over here, so let's go ahead and get it started by pulling these guys and these guys, and this guy right here is also a piece of extrusion. All right. Now, like I said, we do actually have these type of devices in medical facilities, so you might actually be required to take a look at one of these someday. So at the very least, just take notice of my precautions, because it is a high voltage device. And they're not very expensive, so yeah, you could just buy a replacement, but maybe you're curious and you want to fix it. I don't know. Right. This screw right here just feels like it's slipping and slipping and slipping. Wow, this whole thing's just gonna fall apart. This is where it's going to be absolutely essential to make sure that grid is discharged. Okay, so these guys should just pop off. There we go. And I've got that screw. You can tell that it's not made very well because the threads are so rudimentary on it. So what I'm doing is I'm pulling up on it since the thread is kind of boogered up. There we go. So you pull up on it and it helps it come loose. You can see it's threaded into extrusion, which is wrapped in plastic. So they have like a C-channel plastic right there, and they have the extrusion going down inside it. That's cool. Very cool. I love seeing people's manufacturing techniques because it's definitely built for cost. There we go. Nice. Okay, so now this top plate should pull off. We're just going to slide it. Come on. Or can I just pop it off? Nope. I don't want to cut myself. That's the thing about extrusion, is it's very sharp. Oh, the sticker. See the sticker right here? Yeah, that sticker is what's preventing me from sliding it off. There we go. All right, stand it back up. And you guys get to see all the magic. All right, well, I'll tell you what. We don't want those guys floating around. So these are the springs for the gate. So the side gate right here, they ride in the channels right here and right here. All right, so we have 2 different boards, and I see some problems immediately. Man, okay. Well, that kind of sucks. Let's go ahead and bring you in close so that you can see what's going on, because this guy, it is fixable, but is it worth it? I don't know at this moment. It looks like it had a catastrophic failure. Let's do it. Boop. Here we go. All right, take a look at this. Here is the capacitor board. So this is the guy that they're charging up, and it's discharging across the grid, I think. Let's see. We have a whole bunch of diodes down the side. So these are all rectifying diodes, I believe. Oi, right here. See all these guys? I think they're rectifying, and then it's storing it in these capacitors. Right? And that does go straight to the grid. Okay, so this guy right here comes down here. You can see that they plug in right here to the grid. So that part of the circuit is working absolutely fine. We know that because it's zapped. All right. And that comes from right here. So we know we got power right there. Now, the point of concern is we have lost the exciter or the ballast part for both the lamps. And take a look right here. See that? It should look like this guy over here. In fact, they're exact identical circuits, which is also kind of cool because that means that I can take a look at these components and I know exactly what I need to replace over here. But I had a spontaneous failure of, it looks like this guy. And it looks like it also blew out this guy right here. And my lighting is not that great, so I can't really see what they are. I'll have to put it under the microscope. I have, here, tell you what, this is the perfect opportunity to use AI. I also want you guys to take notice of this guy and this guy. You see that? Both of these guys are bulged out, and I don't know if they're the root cause. Like if they shorted, they could have created a lot of heat over here. It's possible. I don't see very many other components that are affected. So it's just these two, and it looks like there's just some heat that got on this guy. Let's go ahead and let's see what that component is. High voltage NPN power transistor, a variant of the 13003. Okay. Interesting. These power transistors designed for switch mode power supplies. Yep. Well, that already, we kind of knew that. So we've got an NPN there, we got an NPN here, and then we've got this little green guy right here. It says the green molded film capacitor, and it tells me that it is a 10,000 picofarad or 0.01 microfarad, 10 nanofarad, 0.01 microfarad. Leading 34 is a series or manufacturer identifier. See, that's one of the cool things, guys, about using AI, is it allows me to see what these components are. Yeah, so that means I got to replace this guy here and this guy here. All right, well, I'll tell you right now. There's some other funky stuff going in on here. So you see that we're dropping 0.6 of a volt on this side. And then when I reverse the leads, see how it says OL? That's a good result. 0.09. And of course they are in circuit, so we could be also introducing a short someplace else. this guy right here is almost definitely shorted. Okay, these capacitors right here, see how they're bulging out, this one and this one? These guys here are almost definitely shorted. I have back here, whatever that guy was, that looks boogered up. I have no idea. It's glass. And look at, it's all shattered. Look at that. Barely even touching it. The thing fell apart. What was that guy? So this board took a heck of a shock, whatever it was, and now it's defective. Okay, 0.5. And when you reverse the leads, well, L. See that? That is a correct result. So that little diode right there is good. Let's see. Come on. 0.08. This one's shorted. Not necessarily the component, but something on this rail. So the way that we would normally do this from here forward is you want to cut the circuit in half, remove one of the components, like one of the diodes, and then test the diodes on this side or on that side, and work your way back and see, are you still shorted? Now these defective components right here, always remove the defective components first, the ones that you know are defective, and then start testing for shorts on your semiconductors, your diodes and stuff. So in this case right here, I would have to remove this guy, this guy, this guy, and this guy. But notice right here, see the PCB, how it's charcoal? My PCB, oh, there's a resistor that was in between them. You see that? Oh, I forgot about that right here. So that resistor right there is also charcoal. And actually, it looks like the resistor is what blew up. Because my PCB is charcoal, I would have to grind that away, which I could do because there's no traces on the side. You see that? It's all through hole. So I could grind it down, but you cannot put another component back in with it charcoal like that because carbon is conductive. And all it will do is it'll create another pathway, and eventually it will create another failure. If it doesn't right now, it will eventually. So step one, remove the known defective components, then test your other semiconductors. Now this guy back here, I think that's my incoming power fuse right there. You see my incoming power goes right through that. So that's just a fuse. It doesn't have a, it just shows a flat line right there. But so that fuse would have to get replaced. It's axial, so that means that it's got wires coming out the two sides. So you just find another axial fuse to put in there. And this guy's not going to pull very many amps, so probably like 2 amps or something like that would be plenty for this guy. But remove the components, test for shorts. I'd have to grind away at the circuit board, this guy right here. And I might actually get bored enough to do it. I don't know. We'll see. But at this point, you can see that half my lamps are being powered by this side over here, which is this switch mode power supply. And then we got this side over here, which is the good side. Now, the only good thing it does for us is it creates a reference. This is not a Gen 1 device. This is going to be probably a Gen 2 device because it does have a DC circuit. I was definitely wrong about that. Now, I could replace this fuse right here and use one of the lamps. This lamp over here is still going to be good. It just, because this shorted, this guy right here popped. So I would have to take these components off, clean up the board, replace that fuse, and that would only power this switch mode over here. And I would be able to light up one of the lights. In fact, let's see. The blues are the defective lights, so the top light would be defective. You can see that right here. Yeah, blues are the top bulb, browns are the bottom. Browns are going to this switch mode right here, so this one's still good. So there you have it, guys. Interesting. Interesting. Well, unfortunately, you know, I will see. Maybe I'll do another video where I actually repair this guy. we'll see. Some of my repairs I do off camera, and I do get them up and going because I just don't think that you guys are that interested in seeing that kind of content. But anyway, we could get half of this guy back up and going. It would just require removing these components and cleaning up this side of the circuit. In fact, probably removing these diodes right here so that this side is not getting rectified. There you have it. Remove those diodes. That removes power from this entire side. Wouldn't even necessarily need to clean that up, to be honest, because once you remove those diodes, you have no AC power on this rail, just on this side. Okay? So those two diodes are for that side, those two are for this side. So half this device could be returned to service, the other half not so much. Maybe that's what I'll do. We'll see. Anyway, guys, I hope you find this a little bit interesting. A final reminder that these grids are high voltage, and if you are uncomfortable with doing those kind of repairs, do not open up that device. If you are novice in any way, I understand your will to want to pull things apart, but this is a hazard because it's high voltage. So do this kind of stuff only under supervision, all right? These things are technically disposable. They're only $20 to $30. If anything, don't risk it, guys. It's just kind of cool to see what happened, and maybe we can remedy it. In this case, I can. I'll just remove those two diodes right there and we'll be good to go. So guys, I hope you like this video. If you do, give me a thumbs up, and stay tuned for another video. I got a couple good ones coming up this weekend. I'm here to help you guys with any of your test equipment needs, whether you need a quote or you just have a question about functionality. It's no problem. Just go ahead and shoot me an email at jbarber@bcgroupinternational.com or justin@betterbiomed.com. It's my pleasure to help you.